Hello, good morning. Hi, my name is Jeff Bowen. I'm the Director of Library Programming and Public Affairs. And on behalf of Pepperdine Libraries, I'm so delighted to welcome you to today's talk by Joel Klein titled A Crash Course in the History of Alchemy and Why It Matters to Chemistry. Here at Pepperdine Libraries, we make it our mission to positively impact learning in our everyday work. And I'm particularly excited how today's talk bridges history and science and is informed by centuries-old objects from the collection of a world-renowned cultural and educational institution. And speaking of the sciences, I want to give a shout out to Dr. Jane Gansky for bringing, her chemistry students. Dr. Gansky has partnered with us on quite a few initiatives, including organizing a recent workshop by a visiting professor who led a demo in the chemistry lab on historical methods of ink making. And just last night, I saw Dr. Gansky at a student's capstone presentation, and that student, Sailor Stottlemyre, under the guidance of Professor French, also here, under the guidance of Professor of French Studies Kelly Marshall, has been translating our special collections copy of Marie Curie's Isotopy and Isotopic Elements from 1924. So it's so encouraging to see Pepperdine faculty partnering with the libraries on these kind of interdisciplinary initiatives. Today's talk is being recorded, so during the Q&A phase of the event, I'll be walking around with a microphone, and I kindly ask you to speak into the microphone so that it gets picked up on the recording. And now it is without further ado that I introduce today's speaker. Joel A. Klein is Molina Curator for the History of Medicine and Allied Sciences at the Huntington Library, Art Museum, and Botanical Gardens, where he stewards the history of medicine and pre-1800 science collections. He received his PhD in the history and philosophy of science at Indiana University and has had postdoctoral positions at Columbia University and the Science History Institute. In his work, Dr. Klein studies the history of early modern medicine and science with a focus on the intersections among medicine, chemistry, and matter theory in 17th century Germany. He is writing the book Chemical Life in Early Modern Europe, and he works on several digital projects, including the chemistry of Isaac Newton. Please join me in giving Dr. Joel A. Klein a warm welcome.
Thank you, Jeff, and thank you all for having me. It's very nice to be here. I was telling Jeff that I had a title for this talk earlier, and it was Fiery Trials, and I decided to change it. So yes, just a little bit about me beyond what's in my official bio. Actually worked for several years as a chemist after doing my undergraduate degree in chemistry. I worked at a biopharmaceutical company, which is now called Sarepta Therapeutics, SRPT on the stock exchange. Not doing well. And yeah, so at some point I decided that lab work in chemistry wasn't for me. My lab partners and colleagues made me nervous. And I decided to pursue a PhD in the humanities and the intersection of history and science. And that's kind of where the talk that I'm going to be giving today comes from. So today we're going to look at the history of alchemy. What was alchemy? Where does it come from? And after that, we'll turn to some alchemical imagery and famous alchemists and conclude with a look at alchemy's influence on the emergence of the discipline that we know as chemistry. So real fast, can you tell me what you think of when you hear the term alchemy? Anyone? Just something that springs to your mind. Gold? Making gold, right? So not just going out and finding it, but actually making it. Anything else? The Philosopher's Stone, that's exactly right. Yes. We'll have a little bit more to say about Harry Potter soon as well. So yes, you might think of turning lead into gold, charlatans faking the production of gold, also sometimes silver. Maybe you think of bizarre imagery, or perhaps predecessor to chemistry. So what was alchemy? Oh, sorry, I'm behind. And like I said, we'll have more to say about Harry Potter. So alchemy is often simply defined as the chemistry of the Middle Ages up through about the 16th century. Really, it goes on, though, beyond that into the 17th and the 18th century. The term is used today specifically to refer to the transmutation of base metals like lead or copper into so-called noble metals like gold or silver. And often the highest goal of the alchemist was to produce the so-called philosopher's stone, a chemical agent that would allow an alchemist, an adept, to transmute base metals into gold and perhaps even prolong life or heal a variety of diseases. So alchemy was also many other things. Some people sought a substance called the alkahest, a universal solvent that would dissolve every substance in the world and heal the sick from a variety of maladies. And you chemists, I know, are wondering, if it dissolves every substance in the world, how are you going to put it in a container? Very good question. So this is a good starting point, but it doesn't really capture the entire scope of alchemy throughout its very long history. So we need to define some terms and draw some distinctions. So throughout its history, the term alchemy was used to describe not only the process of transmutation, and the words that are used for this are based on the Greek. So you've got chrysopoia, which means gold making, and argyropoia, silver making, but also a very large number of processes that are relatively similar to what chemists do in modern laboratories. So the practice of alchemy incorporated processes like distillation, used to make alcohol, strong acids, used, for instance, in the etching of copper. You have assaying techniques like cupellation and cementation, processes used to determine the purity of metals. Also fermentation, the production of salts, and even the production of dyes. So at the same time, we'll also see today that alchemy was sometimes associated with particular mystical, quasi-religious philosophies such as Hermeticism, Gnosticism, and Neoplatonism. So we probably don't have time to get into the specifics of all of these philosophies, but we'll see some details arise as we look at the origins of alchemy. So as you can see, the history here is rather complicated. And one thing historians have done to try to simplify matters is to use early modern vocabulary. So when we discuss the early modern era, before chemistry and alchemy had been separated from one another and chemistry had been professionalized, we use different words. So we've taken to using, sorry, you get the idea. We've taken to using early modern spellings. So if you hear someone or you read of someone using chemistry with two Y's, this is an early modern spelling to signify that alchemy and chemistry really had not been separated in any meaningful way, even into the 18th century. So you've got, for instance, Robert Boyle's work. He's often called the father of modern chemistry, which is crazy. Boyle was an alchemist himself. He called his book The Skeptical Chemist. And then you have some other early works there. So where did all this come from? To find where alchemy came from, we have to travel back to Hellenistic Egypt in the early Christian era in about the 1st century. Before this time, the Egyptians had developed sophisticated methods of working with metals, including the making of alloys and the synthesis of artificial gemstones. And these processes made their way to Hellenistic Alexandria. So the first texts that we have that bear witness to this alchemical tradition date from about the 3rd century. These are called the Leiden and Stockholm papyri. These documents contain practical workshop recipes regarding metals, and importantly, the imitation of valuable metals like gold and silver. So the first truly alchemical texts discuss more than just practical recipes. They also contain a body of theory about the nature of matter and how substances change. So the first alchemical text that we have was written by an individual named Zosimus of Panopolis, and his text has recipes very similar to the earlier texts, but an attached philosophy and theoretical understanding of the nature of matter and the nature of change. And naturally, this was appropriated from earlier Greek philosophy. So we only have scraps from Zosimus's text, but from these texts we learn, from these little bits of text scattered here and there, we learn that by his time in the 4th century, various alchemical schools had already arisen. Zosimus's primary goal was the transmutation of metals. So again, that's changing one metal into another one. And when he describes these processes, he does so in a very secretive fashion. And this use of secrecy and the hiding of names would become a hallmark of alchemical text. So Zosimus, for instance, described mercury, so the metal mercury, as the silvery water, the hermaphrodite, that which flees without ceasing. And he also uses the phrase our lead to refer to the mineral stibnite, which is antimony trisulfide, an ore of antimony that you can find in nature. So this type of secrecy, the Germans have given a name to. They call these cover names Decknamen. This becomes a standard in alchemy. And as we'll see later, different compounds, elements, apparatus, and processes were symbolized. So, for instance, mercury is often represented by a particular symbol. Gold is represented by a particular symbol, so forth. So why all of this secrecy? There are probably several forces at work here. So first, various rulers and governments have outlawed chemical books over the course of history because they contained information ostensibly about how to create very valuable metals, precious metals and gems and so forth. And of course, this would be horribly destabilizing to currency, the value of gold, and society in general. Also, secretive language was used to protect trade secrets from those uninitiated in the alchemical arts. And in addition, alchemists like Zosimus were writing during a time in which philosophies like Gnosticism were very much in fashion. So his writings used many standard literary tropes from these traditions to associate alchemy with higher or divine knowledge. So for instance, Zosimus writes as if alchemical texts were divinely revealed to him in a dream. And he also uses a Gnostic account of Christian religion in which human beings must reject their material body in order to ascend to a higher spiritual or divine realm. So while Zosimus wrote within a framework of Gnosticism, it isn't entirely clear what the relationship is between philosophies like Gnosticism and actual chemical, what we might call laboratory processes. So our next stop in our very brief and very crashy tour of the history of alchemy has to be in the medieval Islamic world. So after the fall of the Roman Empire, we see a dramatic decline of interest in natural philosophy, of which alchemy was an important part, caused by the destabilization of society, especially the places that were the Western Roman Empire. So, even though natural philosophy wasn't generally happening in the West, Islamic societies began to take a serious interest in Greek natural philosophy and medicine, and that included alchemy. So to understand these Greek and Latin texts, they set to work on one of the largest and most important translation efforts in the history of the world. So this process of translation was hugely accelerated with the rise of a place called the House of Wisdom in Baghdad, which was founded by an individual named Al-Mamun and headed by Hunayn ibn Ishaq, who lived in about the 9th century. He was a Christian and an Arab. He was a physician who had studied perhaps in Alexandria, and he was versed in many languages. So translation continued at a very rapid pace after Hunayn ibn Ishaq, and by about the year 1000, almost all of Greek medicine, natural philosophy, and mathematics had been translated into Arabic and was being studied and used. So in addition to translating and perpetuating Greek ideas, many individuals in the Islamic world made significant contributions to alchemy. In fact, the very word alchemy comes from the Arabic, in which al is merely the definite article, and then you have the word chemia. It just means the chemia, the chemistry. Chemia comes from the Greek. So much like other words, algebra, alkali, algorithm, etc., they have an important philological past in Arabic. So one of the most influential of the Arabic alchemists was an individual named Jabir ibn Hayyan. This is often Latinized as Geber. He played a huge role in the history of alchemy, but like so many other alchemists, he is a very mysterious figure. We don't know if the writings attributed to him were actually written by one person or many, and we really don't know if a person named Jabir actually existed. And this is a common problem in alchemy. As Johns Hopkins professor Lawrence Principe puts it, anonymity, pseudonymity, secrecy, mysteries, false trails, and subterfuge fill the entire subject of alchemy from beginning to end. So why I chose historian of alchemy is something that I would do with all of this difficulty. I do not know exactly why, but it does make it very difficult to be a historian of alchemy. So it appears that there was a group of Jabirian alchemists in the 8th and 9th centuries, and their writings were very influential. Their most influential idea was that everything is made of two things, mercury and sulfur. So this isn't in the modern sense. These were so-called principles associated with particular properties. So mercury is associated with properties of fusibility, weight, and metallicity. Sulfur is associated with color, smell, inflammability. Something like tin or lead would be thought to have lots of mercury. And iron and copper ores, which react strongly with fire, were thought to have lots of sulfur. So gold was thought to have perfectly equal parts of sulfur and mercury. So the mercury-sulfur theory did many things, and perhaps most notably provided a theoretical explanation for transmutation of one thing into another. If all metals are simply mixtures of mercury and sulfur, adjusting the balance of these or purifying one or the other can lead to changes from one metal to another. So the mercury-sulfur theory was held by natural philosophers and chemists all the way up really through the 18th century. It was a dominant way of understanding chemical matter and matter theory for about 1,000 years. And it actually lived very well with the other major matter theory, which stretches back to the ancient world, which is that of Aristotle, who believed that everything is made up of 4 elements: earth, air, fire, and water. And then even more fundamentally, everything is made up of hot, cold, wet, and dry. Unlike Plato, who thought that everything is made up of triangles. So throughout this period, we see many what are called pseudepigraphical texts. This means a text purported to have been written by basically someone else, people pretending to be other authors. And an especially important document in this vein is the so-called tabula smaragdina, or emerald tablet. It claims to be an ancient text written by an individual named Hermes Trismegistus, that is thrice great Hermes. All the evidence that we have points to an Arabic composition, probably in the 8th century. In any case, there was a body of texts attributed to Hermes Trismegistus, the so-called Hermetic corpus, which is a mishmash of documents, some dating back to antiquity, some from the late Christian period, and all with a mystical, religious, and quasi-magical bent. But none are explicitly alchemical. So this translation should give you some idea of the emerald tablet, where in English translation it says, "'Tis true without lying, certain most true, that which is below is like that which is above, that which is above is like that which is below, to do the miracles of only one thing." It continues, "The sun is its father, the moon its mother." So you can see, it's a mystical text, difficult to interpret, could mean anything. There were many alchemical interpretations of Hermetic literature like this, even though it wasn't explicitly alchemical. So how did Arabic alchemy, with its sulfur mercury theory and understanding, make its way to the West? This was done through a process of translating Arabic texts into Latin. So probably the first alchemical text to be translated into Latin was a book given the title De Compositione Alchemiae, on the composition of alchemy, which was translated in the year 1144 by Robert of Chester, an English monk who was working in Spain. Spain is at the intersection of the Arabic world and the rest of Europe. So after texts like these were translated in the 12th century, alchemy came to flourish in Europe for about 600 years, using the same secretive language and even the same pseudonymous authors. So for instance, one particularly famous alchemical text, the Summa Perfectionis, was allegedly written by Geber, by Jabir ibn Hayyan. But it was almost certainly written hundreds of years later by a late 13th century Italian Franciscan friar named Paul of Taranto. This is a much later printed edition of Geber, about 100 years or so after the advent of printing in the West. So there were great controversies throughout the Middle Ages about whether transmutation was possible. And for many during this period, alchemy came to be associated with charlatanism and fakery. So you might be familiar with Geoffrey Chaucer's Canon Yeoman's Tale, one of the Canterbury Tales from the 14th century, in which an alchemist is ridiculed for his shady dealings and charlatanry. Have any of you been to the Huntington to see the Ellesmere Chaucer? How many of you have been to the Huntington? A good portion of you. Well done. Nice work. So one of our most famous late medieval manuscripts is this particular manuscript of the Canterbury Tales called the Ellesmere Chaucer. It's one of two manuscripts of the Canterbury Tales, which was written by someone who likely knew Geoffrey Chaucer, so it includes a little portrait of him. Moving to the 14th century, we see various rulers in France, England, and Italy banning the practice of transmutation. So in 1317, John the 22nd issued a papal decree that said transmutation was impossible and that alleged transmutations are counterfeit and mere illusion. And this proved very influential, not necessarily on stopping alchemy, but in making it more secretive. So, whereas earlier medieval alchemical texts like Pseudo-Geber's Summa Perfectionis were relatively straightforward descriptions of laboratory processes, later alchemists became even more secretive in response to the increased criticism of alchemy and the related prohibitions against it. So many alchemical works became even more allegorical. So, for instance, in the texts by an author claiming to be Arnauld of Villanova, who was definitely not a real individual named Arnauld of Villanova, so we call him pseudo-Arnauld. The quest for the Philosopher's Stone is allegorized as the life of Christ. So as Arnauld, or rather pseudo-Arnauld writes, Christ was the example of all things, and our elixir can be understood according to the conception, generation, nativity, and passion of Christ. So authors like Pseudo-Arnauld continued using decknomen, cover names, to hide their meaning from the uninitiated and from rulers like Pope John, because they didn't want to run afoul of authorities. This religious language, though, also had the effect of enhancing alchemy's status by transforming it into a type of holy knowledge that could perhaps only be received as the gift of God through a process of personal revelation. So that's not to say that alchemy wasn't religious before, but really especially the Christian elements of alchemy amplified in this period. So at about this time, we also see the rise of several important alchemical genres that similarly conceal and reveal information, but through different means. And one of the most interesting is the use of images. So one of the earliest texts to incorporate the use of allegorical alchemical images is a manuscript called the Aurora Consurgens, or Rising Dawn. And here you have a male figure riding a lion, jousting with a female figure riding a griffin. So it's a male sun, a female moon. The female moon carries a shield with the sun on it. There's lots of wacky stuff happening here, right? You also have a phoenix rising from what the text of this manuscript tells us is a pile of putrefying eagles. You have this two-bodied, dual-sex individual holding a bat, and I think it's a rabbit. You know, this stuff is lit, right? It's the stuff you hope your dreams are made of. You have another important text which goes on to be printed later on called the Rosarium Philosophorum, or the Rose Garden of the Philosophers, which started with a German poem from the early 1400s, which was later spliced into Latin prose, and then finally in the 1500s, images are added, one of which you can see here. So these are from the Rosarium Philosophorum. These are, I guess, another kind of dream. So Many of these images are sexual in nature. Often you've got copulating couples in flasks. This usually represents the conjunction of mercury and sulfur, sometimes silver and gold. Their love creates what the author called a hermaphrodite. It's the term they used in the era. It's the perfect mixture of mercury and sulfur, which eventually gives rise to the Philosopher's Stone. I once gave a talk. Actually, the first talk I was invited to give when I was a graduate student was at a public library that was, they were doing talks that had to do with the National Library of Medicine's traveling exhibition on Harry Potter and the history of science. So they invited me to give a talk on Harry Potter and the history of alchemy. And they told me it was going to be an audience, of young adults. And I gave, something similar to this talk with similar imagery, and it was only 11-year-olds and below. And I had to rapidly change the nature of the talk as I was giving it. So some of the most famous images in alchemical history were printed. And of course, they have a much larger footprint in culture because they can be spread so widely through this relatively new invention of the printing press and movable type. So probably the most influential images are from this 17th century text called Atalanta Fugiens, or Fleeing Atalanta, by Michael Meyer, who was a court alchemist. He moved around a lot, but he spent most of his time in Prague at the court of Holy Roman Emperor Rudolf II, so one of the most powerful people in Europe. So this book is a series of emblems, which are joined by a series of fugues. You can, if any of you are musicians, you can actually go through and play these and sing along. There are actually some recordings of the music, if you can find them on Spotify. But it gives you a flavor for the text. So the secrecy is continuing. The idea is that the quest for the Philosopher's Stone is hidden within the symbolism of these various emblems, the poem that goes along with them, and then also the fugues. And it's just this mishmash of classical imagery, religious imagery, natural philosophy that goes on. Another image from Atalanta Fugiens. And this is from a different author. So this is another image that's also from the 17th century. It's an enigmatic illustration from a text by another pseudonymous author named Basil Valentine. So this is from a printed text called The 12 Keys of Alchemy. And here is a handwritten description of this text from a late 17th century author. So 2 women clothed riding on 2 lions, each with a heart in her hand of this form, then it draws a little picture. The right-hand lion farts on a company of young lions behind it and bites the snout of the left-hand lion and tears him with her paw. This lion, by her farting, which signifies her aerial form and young ones, and being on the side of the hearts next to the moon, and he biting and tearing the other lion signifies the female, and it goes on. So as you can see, this is an accurate description of what is happening in the image. You didn't expect to see something like this when you woke up this morning, did you? This manuscript is the handwriting of none other than Isaac Newton, who of course is also famous for co-inventing calculus, being the first to produce a mathematical description of gravity and the idea that one thing pulls on another and everything's pulling on everything else. Optical experiments, all of that, right? This is the same Newton. He was an alchemist for most of his life. So the emerald tablet that we looked at before, and the translation that I gave, that's actually Newton's translation. And he was one who sought to find an alchemical interpretation of the emerald tablet of Hermes Trismegistus. So Newton read these and other alchemical texts. He sought to interpret them as chemical processes in the laboratory. So you can see he's interpreting those lions and the various things that they're doing to signify that there is a chemical compound in the laboratory which needs to do something like sublimate and go into aerial form. Perhaps enclosed in a vessel or what have you. So we haven't deciphered exactly what either Basil Valentine intended with this image or precisely what Newton thought it showed, but there are many other areas from Newton's alchemy where we can see that he was definitely trying to find laboratory processes from previous alchemical texts. So here's another image from the same text that we know Newton tried to interpret. This is Valentine's third of 12 steps to attain the Philosopher's Stone. And here the dragon, in particular the dragon's blood, represents a particular red crystalline compound, while the rooster in the background signifies the dawning of the morning and the rising of the sun. Of course, the sun almost always refers in alchemy to gold. The fox we have discerned from the text refers to aqua regia, a combination of hydrochloric and nitric acids, which can dissolve gold. And thus, this step in the alchemical process involves the dissolving of gold in aqua regia and eventually creating gold chloride, which is a lovely orange-red color. This is, in this text, the dragon's blood. So we know this not simply from looking at this image, but also from the context of the book. So no one would expect you to look at this image and know that it refers to gold chloride. But that's kind of the point. These images were meant to hide information as much as they were meant to reveal information to people who are in the know. And there's some gold chloride. So did Newton actually do any of this alchemy? Was he really trying to make the Philosopher's Stone? In short, yes, he was. He did a lot of stuff in the laboratory. He wrote really just as much on alchemy as any of his other pursuits. And we actually have at the Huntington a large number of his manuscripts. We have the third largest collection of Newton manuscripts in the world, and a good number of them happen to be alchemical, including a famous manuscript called the Praxis manuscript, which my PhD advisor, Bill Newman, who wrote the book called Newton the Alchemist, he thinks is one of the most important manuscripts for really decoding Newton's alchemy. So a good example to show that Newton really was seeking the Philosopher's Stone is his description of the creation of a so-called star regulus of antimony, a substance that was used in several important steps along the way to making the Philosopher's Stone, according to many alchemists, became very popular in the 16th and 17th centuries. So I won't read through all of this here, but you see, this is Newton's manuscript. He is describing a very real process involving particular metals. So each of the funky signs that you see in the text, some of these here, that represents a particular metal. So while I was in graduate school, I got to work with Professor Newman on a project called the Chemistry of Isaac Newton project, where we have used this recipe to create this so-called starry regulus. And what's actually happening here, if you carry out the description of Newton's laboratory notebook, you have the reduction of stibnite, antimony trisulfide, with a metal such as iron. So toss some stibnite and iron into a furnace in a crucible, and then you heat it very, very hot, you pour it out, and as the pure antimony metal cools under the slag, the antimony actually crystallizes and makes this kind of starry surface. So where did Newton get this recipe from? Did he create it himself, or was he interpreting this from another alchemical text? What does this have to do with the Philosopher's Stone? In fact, one source for Newton's recipe for the star regulus comes from one of his favorite authors, another pseudonymous individual. This is a guy named Irenaeus Philalethes, which means peaceful lover of truth. We know this is actually the pseudonym of a guy named George Starkey, who was a Bermuda-born alchemist who attended Harvard College. This is, of course, in the early colonial years of places like Harvard, before Starkey eventually moved to London. So Philalethes wrote in a text, which we do have at the Huntington, called The Open Entrance to the Shut Palace. Just to warn you, there is some strange imagery in this text. So this chaos is called our arsenic, our air, our luna, which means moon, our magnes, our calibs, but in diverse respect, because our matter undergoes various states before our regal diadem, our royal crown, is extracted from the menstrual blood of our whore. So learn who the comrades of Cadmus are, and who the serpent who ate them, and what the hollow oak on which Cadmus transfixed the serpent. Learn what the doves of Diana are, which conquer the lion by beating him, the green lion I saw, which is really the Babylonian dragon, killing all by means of his venom. So, decoded, this is an extremely abbreviated and elusive recipe for so-called sophic or philosophical mercury, which is supposed to be something that amalgamates with gold, but penetrates very deeply, even more deeply than mercury, breaking gold down to its primitive constituents so that you can eventually make the Philosopher's Stone. So in this metaphorical passage, the whore is stibnite or antimony trisulfide, a mineral ore form of antimony, used at this time to purge gold and quicksilver of its dross. So stibnite is the source, the indiscriminate mother of all other metals and minerals. And then this regal diadem extracted from the menstrual blood is the star regulus of antimony, which, as we've seen, can be produced from stibnite. And the green dragon refers to stibnite, while the eating of Cadmus's comrades refers to the addition of iron. So you get the idea. You might ask, why are we just learning about Newton's alchemy now? He has, after all, been dead for hundreds of years. Newton died in 1727, and by that time, alchemy had become even more scandalous than when he practiced it earlier in his life. It was associated, or it came to be associated with useless medieval knowledge. It was looked down upon by Enlightenment philosophers. So when his alchemical papers were discovered, some were scandalized that one of the greatest scientific minds in history had devoted himself to what many thought was a fool's errand. His alchemical papers were deemed unworthy of publication, and it wasn't until 1936 that they were auctioned off, which is actually the sale at which most of the Huntington's collection was purchased by a collector named Roger Babson, who founded Babson College. In any case, it's only been in the past 40 years or so that scholars have begun to take documents like these seriously. I should note also, at the same sale, another aspect of Newton came to light, which is that by the standards of his day, he was a heretic. Newton was a very serious anti-Trinitarian. He hated the idea of the Trinity. He wrote about this to some degree, but generally knew that, he was at Cambridge, a place where to be a professor, you had to be in pretty close cahoots with the English church. And he knew enough to keep his views really strictly in manuscript form. So we actually have a very famous manuscript of Newton's at the Huntington, which is all about his interpretation of the Temple of Solomon. It includes this big page, folio-sized page drawing of the Temple of Solomon. Newton sought to decode the geometry and the architecture of the Temple of Solomon because he thought it held divine secrets. Okay, why don't we cash out a bit about exactly what Newton's alchemy means, or what I think it means. So when we actually look at Newton's alchemy, and we don't simply dismiss it because we're confronted with bizarre images of farting lions and hermaphrodites and so forth, we're struck that Newton thought about his alchemy in a similarly rational, careful, and methodical way as with his other endeavors, much the same as he approached optics or physics. And in at least one instance, he drew from alchemy to explain what was happening in physics. So you might be familiar with his famous optical experiment separating and then recombining white light. If you're not familiar with this image, you've probably seen it on Pink Floyd's album. The idea here is you take light, you take one prism, you separate it into its colors, and then you take another prism and you can recombine it into white light. Newton used a chemical term, which would have been familiar to any chemist at the time for what was happening here. The chemical term he used is redintegration, which is used by alchemists to describe analyzing matter into its constituent parts and then resynthesizing the original compound. So, in the early 17th century, there was a chemist named Angelo Sala who wrote a book called The Anatomy of Vitriol, where he describes the redintegration of vitriol, which is basically iron or copper sulfate, where you take it apart into its components, into its building blocks, and then you recombine those together to get the original thing. So a bit more on this in a moment. Also in Newton's alchemy, we see that many of the procedures that he described are highly technical and difficult to carry out. So we know that these pictures of dragons and green lions are actually code words that hide a literal chemical meaning. So it's not easy to figure out what the code hides, but in several important instances, as you've seen today, it can be done. And just like his work in physics and mathematics, Newton's alchemy combined theory and practice. It involved careful reading with hands-on experimentation. It showed that Newton had extraordinary attention to detail, and it was meticulously precise. It demonstrated what Newton thought to be his best quality. So when Newton asked, what separates you from all these other people, all these other bozos in the Royal Society who haven't done the amazing things that you've done, Newton said, my most important trait is what he called patient thought. Newton was seeking to understand the fundamental nature of the universe, and when he had a question that he wanted to answer, he never gave up until he had an answer that was satisfactory. Whereas most people would give up, he was very patient and he just could think his way, usually on his own, which is, he was a weird guy who didn't get along with many people. Anyways, there's little reason to think of two completely distinct Newtons. This is the same for people like Robert Boyle. Robert Boyle, by the way, learned alchemy from George Starkey. He traveled to London. He corresponded with Boyle. Boyle was a very wealthy individual, famous at the Royal Society, famous for air pump experiments. You're familiar with PV equals nRT, ideal gas law that begins with Boyle's law. Pressure and volume are inversely related. So what can we say about alchemy's influence on later science? We now know that transmutation is impossible unless you have a particle accelerator. Did we learn anything else important from alchemy, or was it all a fool's errand and for naught? In short, historians of science in the past 30 years have made the case that alchemy was indeed important in the emergence of modern chemistry, and to bigger questions in the history of science. So I'll finish here just mentioning a few areas where I think that is the case. The first one is somewhat obvious, we've already looked at. Alchemy bequeathed to chemistry a huge variety of technical and industrial processes and tools, from massive distillation vessels to techniques of analysis and synthesis. Alchemy cannot be disentangled from those areas that we might want to call proto-chemistry. And this is the reason historians today have used the word chemistry with two Ys. But also, alchemy was important in the development of important concepts central to the period often called the Scientific Revolution. So first is the idea of atomism. This is the guy that I study. His name's Daniel Sennert. He's a professor at the University of Wittenberg, and he did important chemical experiments that he wrote about. This is an image showing all the chemical apparatus that he included in his book, The Institutions of Medicine, in the section on chemistry. Sennert did a really important experiment that he called the reduction to the pristine state, where he started with silver. He dissolves this in nitric acid. He passes this through a filter, showing that it all goes through the filter. He then precipitates this with potassium carbonate and puts it eventually into a furnace and gets back the original silver metal. Sennert used this to challenge ancient philosophy, which held that, according to Aristotle, everything is basically homeomerous. There are no distinct particular chemical elements, and there's no such thing as atoms. Okay, for Aristotle, the idea of atomism is just ridiculous, and it cannot exist. This has to do with his idea of motion, and it all ties into Aristotelian philosophy, and it was the prevailing understanding of the natural world for, close to 2,000 years. Sennert uses this chemical experiment to say everything is made up of atoms. The little particles of silver didn't go anywhere. They were in solution. This was really influential on Boyle and later individuals who argued for atomism. And long story short, this leads to people like Lavoisier and the Chemical Revolution. You can read more about this in the book Atoms and Alchemy. There's Lavoisier, famously was beheaded in the French Revolution. So beyond atomism, and this idea that everything is made up of building blocks, of elements, the works of the Flemish chemist Johann Baptista von Helmont also capitalized on this understanding of analysis, synthesis, building blocks. So in one experiment, he made glass out of sand and salt of tartar, what we would call potassium carbonate, employing an excess of the latter to produce a substance called water glass, potassium or sodium silicate. So he reacted this with nitric acid and found that a sand-like product was released, which led him to conclude that the grains of sand used in the original glass had been present all along, and that glass itself, despite its uniform appearance, was in fact composed of bonded particles at the microstructural level. This is an experiment very similar to Sennert's, but unlike Sennert, Van Helmont weighed the ingredients that went into the glass, and then he reweighed the final products. He claimed as a result that the sand that went into the glass had the same weight as the sand that was released by analysis with acid. This emphasis on weight is characteristic of his general approach throughout his work. And you might be familiar with his famous willow tree experiment, where he weighed a sapling in its soil and then let it grow for 5 years, and then he weighed everything again, leading to his conclusion that the tree was composed solely of water. But his careful use of weight, gravimetrics, in chemistry led him to an explicit recognition of the principle of mass balance. As he put it, nothing comes into being from nothing, hence weight comes from another body weighing just as much. He came to challenge Aristotle's view of physics in general. So although mass balance had been implicitly assumed by metallurgists and alchemists for centuries, it came to exist in an uneasy relationship with the dominant Aristotelian physics of the Middle Ages. And it really wasn't until the 17th century individuals like Van Helmont that you have an explicit enunciation of this concept of mass balance. Finally, to the question of how alchemy mattered to the history of chemistry, in short, in all these different areas, atomism, experiments that I showed you, alchemy provided an interplay of philosophical questioning and laboratory experiment that distinguished the field from either pure technology on the one hand or theoretical speculation on the other. It's been at the intersection of theory and practice since its inception. And yes, it has a wacky history filled with weird imagery. If you want to read more about this, The Secrets of Alchemy by Johns Hopkins professor Lawrence Principe is very good. Another book by Principe and Newman, Alchemy Tried in the Fire, is also a really good read. So thank you. Couple minutes for questions.
I was going to say we're close to 11 o'clock. So if anyone does need to leave, feel free to sneak out because we probably, we can go over time a little bit if you all want to stick around for some questions.
Hi, thank you, Dr. Klein, for the lecture. It was very interesting to me as a non-chemist. And one thing that caught my eye were the visuals that you use. I really like them. But I'm curious, of the time and maybe after this time, how did visualization in scientific writing or pseudoscientific writing, was it always so detailed at that time? Or when did it really become a little more stripped down, if you will?
That's a great question. It's really not until, late 18th, early 19th century. Even then, illustration becomes really important. I work, largely on the history of medicine, and there's a big fall off in images when the major source of publication ceases to be monographs and begins to be journal articles. And there's less of a need for these large anatomical atlases and things like that. Most of the books that I showed you, some of them are in manuscript form. They were prized pieces of very wealthy people. We have a 10.5-foot long Ripley scroll at the Huntington produced by hand in the 16th century, which would have been a very valuable item, and it would have had a lot of prestige to own an item like that, similar to many of the books that I showed you. So as printing becomes even more widespread with mechanically produced paper and mechanically printed books, you have fewer really big, exciting books, which isn't to say that they aren't still produced, but yeah. Any other questions? Yeah.
Know a little bit about the founding mother of alchemy in the 3rd century. I think her name was Maria, and she felt like her ancient alchemy secrets were being revealed to her by God. Do we know of any other women throughout history that were also associated with alchemy?
There are many women. Maria Prophetessa, very important. If you've ever used the chemical process, in French, the term is, bain marie, Mary's bath, your double boiler, basically. There are many other women in the history of alchemy. One of my favorites, there's a book written by a good friend of mine who's at Brown University, Tara Numedal, and she has this book called The Lion's Blood, which is about a woman named Anna Zieglerin, who practiced alchemy at various courts throughout Germany, and also developed a medicine which she called the lion's blood. I'm not really spoiling this, but it starts at the beginning of the book. She was executed. She ran afoul of her patron and was allegedly burned alive in an iron chair, which you can still see in Braunschweig if you happen to travel to Germany. She actually wasn't killed in the chair, but she was still executed. There are other women as well, here and there. Mostly it's men, but there are some women. Yeah.
Would you say it's an over-exaggeration to say that chemistry would not have developed as fast if it were not for scientists studying transmutation and looking at the Philosopher's Stone?
It's hard to do counterfactual history, but yeah, I think so. There was just there were many reasons for people to go into the laboratory and play around with stuff and try and understand the fundamental nature of matter. So this is what separates alchemy from people who are just doing metallurgy, is they are seeking theoretical explanations for what is happening at an invisible level. So I mean, the area of my work where I see this the most is in this idea that everything is made up of fundamental particles, which is not to say that in the 17th century you have all of the makings of modern Daltonian atomism, but you have a good chunk of it. And I do think, yeah, Lavoisier and the chemical revolution, there are really important things that did come from alchemy. Yeah, yeah, very good question.
Kind of mentioned at the end of your previous answer that one of the defining aspects of alchemy was that it was seeking this kind of higher insight into the construction of the universe. And that, I was really kind of intrigued by your description of Javier Ibn Hayyan's sulfur mercury kind of paradigm. What relevance, if any, does the perspective of alchemy as both a spiritual transformation and a physical transformation have onto modern day sciences? And do you think there can be some insight gained in there in, the study of sciences or even from a pedagogical standpoint?
It's a great question. So one thing I didn't talk about is a reason the history of alchemy is really difficult to do is that there are many people who do not believe, and over the course of the late 19th and early 20th century, many people who have believed that alchemy did not have a laboratory component and it was strictly spiritual. So this came from various thinkers, most notably Carl Gustav Jung, Jung, who believed that alchemical imagery was the eruption of the collective unconscious. And that the things that I've described, Newton doing, nothing was actually happening in the laboratory. It was all a spiritual process, which makes the work of doing the history of alchemy difficult because there are still practitioners of Jungianism who believe that alchemy is a spiritual process. Alchemy in the early modern era, if it had, in Western Europe, if it had to do with spiritualism, it was generally in already established channels of spiritual practice, generally Christianity, and then you have some elements of the Kabbalah, and you have these other streams of thought, Neoplatonism and so forth. As far as how it might influence people today in chemical practice, I don't know. It's difficult to say because most of the ways that people think of alchemy being a spiritual practice today are wrong. It was not a Jungian eruption of the collective unconscious. That's just a misinterpretation of alchemical history. But I suppose some people might take inspiration from this on a more personal level about the intersection of the spiritual with that which happens in a laboratory. Generally, though, I don't think that happens because, as you've seen, the history of alchemy is bonkers. But that's just my take.
Good.
Any more questions?
So, how should I put it? Why do you think this fascination or this interest with alchemy and like turning things into gold persisted over like hundreds of years, but also like across cultures and from Arabic to Western cultures?
It's a great question. Why did it persist even though you can't do it, right? It's impossible to prove a negative, and there are also many processes in chemistry which do show radical transformation. There are various, tricks that you can do as well, which people did do that make it look as if a transmutation has happened. So for instance, if you take an alloy of gold and silver, and then you dip it into a particular acid, making all the silver go into solution, it really looks like you have done some kind of a transmutation and you've changed this thing from one thing into another, and you have made gold. There were many people who capitalized on, tricks like that in order to deceive people. So there were many charlatans, and there were people traveling from town to town, doing these things in order to convince people that you could actually make gold. But also, I think on a different level, things that people are doing in the laboratory do help to explain what is happening in the world. Even if you're ultimately wrong about transmutation, there is a lot that you learn from carrying these things out in the lab. Like that everything is made up of building blocks. There's no good laboratory reason that alchemy fell out of fashion in the 19th century. No one ever did a crucial experiment which showed that you cannot change lead into gold. It fell out largely for political reasons, and because it was just no longer fashionable. At places like the Académie Royale des Sciences in France, it really was just it ceased to be part of the fashion, and people who viewed chemistry as this professionalizing discipline, which would bring great power to the state, were embarrassed that their colleagues still believed in it. Yeah, very good question.
What you're talking about, but I work in 18th century literature, and one of the things that I was thinking about, especially in the answer you just gave, a lot of the writers that I study think about transmigration, and I was wondering if there's any connection between the ways that people are talking about transmutation and then this other idea, and like this ability for people to be metamorphizing, or like things in the world capable of that, and like how all of that might be speaking to each other in some ways, or if there is an overlap from what you're aware of.
Yeah, if something like the transmigration of souls has to do with transmutation and alchemy, it very likely does. I couldn't point to a particular place where that happens, but literary authors have, had a heyday with alchemical imagery, because there's just so much that you can do with these themes of transformation and changing one thing into another thing. So it's throughout Shakespeare, it's explicitly in major works, Ben Jonson's The Alchemist. A problem, though, is once you see alchemical imagery, you can see it everywhere, and it's not necessarily everywhere. So there are a lot of really bad interpretations of paintings where someone says this has to be alchemical, and actually it's not. So it's really tricky. There are excellent scholars who have made cases, but it's just on a case-by-case basis, really. Yeah, don't become a historian of alchemy, not just because the job market in academia is terrible, but it's really frustrating. That's actually not true. You should all become historians of alchemy.
Well, I think that's a great point to end on. So would you join me in giving Dr. Klein one final round of applause?